example, a vacuum tube. This is just 50 years ago. It has shrunk considerably since then, and we want to talk a little bit about this. 50 years ago, this would have taken up several rooms. Now it takes just a spot on our motherboard. If we were to pretend like this little building here is our I/O, the in and out, as we studied, this might be the section of the computer where we get information in and we send information out. 50 years ago, the way we did this, 50 years ago was with cards. There would be holes in the cards. The computer would read where the hole was or wasn't. That would be our binary on-off. And so in this huge building that's very hot because vacuum tubes create heat, we might put this card in there, and this card would be our in and out function. This is how we put information in, and how it would send information out to us. In the old days, 50 years ago, we could run fewer than 100 cards through this to make things happen. It's hard. Today our in and out doesn't do hundreds, but it does billions of calculations in a second. Not hundreds, but billions of calculations in a second. And clearly this is not the size of a room. It's a lot smaller, which is one of the things we're going to talk about today. In the old days, they could have done hundreds maybe in a second. Now they can do billions. We can do billions of in and out functions in a second. If we pretended like this area over here was our processor, and we talked about processors in the class where the actual numeric calculations take place, about 50 years ago, we could do thousands of calculations in a second. 50, 60 years ago, thousands of calculations in a second. Now we can do billions of calculations in a second with our processors as well too. This is not just twice, not geometrically. This is